Okay, so here's our worksheet. Hopefully you haven't given up on me yet. I believe that this worksheet is going to make everything feel a lot easier for you. So this is the things that you need to be able to do related to this whole idea of chirality centers and enantiomers and things like that. Number one, you need to be able to look at a molecule and find the chirality centers in the molecule. And some molecules have multiple chirality centers in them. So we're going to be on the lookout for that. Let's start by just defining again, what is a chirality center? The definition of a chirality center, it's going to be a carbon atom with 4 single bonds to 4 different things. So we're going to start with the very first molecule and we're going to move left to right. And when we're looking for chirality centers, we want to analyze each carbon one at a time and ask ourselves what things are attached to that carbon atom. So we're going to start with this guy right here. And we're just going to simply ask ourselves, first of all, does it have 4 single bonds? Which it does. We can only see one of those single bonds, so that means that it has 3 bonds to hydrogen. And the second thing that we're going to ask ourselves is, are those 4 different bonds to 4 totally different things? Now, they're not, because I just drew 3 hydrogens on there. Those 3 hydrogens are all exactly the same. So that means that that first carbon, because it has 3 hydrogens, it is not a chirality center. It has to have 4 totally different things. So that's a no. Let's move on to the next carbon. First, does it have 4 single bonds? We can see 2 of its bonds, which means it has 2 bonds to hydrogen. And then boom, right there. Because it has 2 bonds to hydrogen, it has 2 bonds to the same thing. It is also not a chirality center. That's a no. So now we're going to move on to the next guy. This guy. What can we see here? So we can see 3 of its bonds. So that means it has only 1 bond to hydrogen this time. That's hopeful. It has 1 bond to hydrogen. It has 1 bond to a bromine. So those are 2 different things. But what about the other 2 bonds? To the right side, it has this 2 carbon branch. And to the left side, it has an identical 2 carbon branch. Because the left side and the right side are identical to each other, it also is not chiral. That carbon is not chiral because it has 2 identical things. Moving on. Next carbon over. We can see 2 bonds. That means it has 2 bonds to hydrogen. It has 2 identical hydrogen atoms, so it is also not chiral. And our last one, this guy, it has 3 bonds to hydrogen. It has 3 identical things, which means it also is not chiral. So this first molecule has none. It has no chirality centers at all. Every one of its carbon atoms has at least 2 identical things attached to it. That wasn't so bad. Let's keep going though. So next molecule, this first atom right there, there's 1, 2, 3 hydrogens, so that is not chiral. Second atom, we can see 2 of its bonds, so that means it has 2 hydrogens, not chiral because it has 2 of the same thing. Next atom, we can see 2 of its bonds, so it has 2 hydrogens, again, not chiral because of the 2 hydrogens. Next atom, this atom only has 3 bonds. In this case, a double bond is counted 1 time, just as a single bond. That's not the right way to phrase that. A double bond is counted as just 1 bond. So this particular atom, let me erase the rest of this. That particular atom that we're focusing on has a bond to the left, it has a bond to the right, and it does have a hydrogen on it. Because it only has 3 things attached to it, it can't be chiral. Any carbon atom that's part of a double bond or a triple bond can't be chiral. And so likewise, the next guy over, it's part of a double bond, so it cannot be chiral, so that one is a no. And the last atom in this molecule has 3 hydrogens on it, so again, another molecule with no chirality centers. Let's put a little note over to the side that when we're finding chirality centers, the carbon atom can't be part of a carbon-carbon double bond or a carbon-carbon triple bond or any kind of double bond. So like a carbon-oxygen double bond, that also would not be allowed, or a carbon-nitrogen triple bond, that would not be allowed. Any double or triple bond, not allowed. So we have 2 molecules in a row that have no chirality centers at all. Let's see if we can find one in the third molecule. So first carbon atom that we come to in this molecule, it has 1, 2, 3 hydrogens, so it is not a chirality center. Second atom that we come to, this one has, the molecule's getting a little more complicated now. This molecule has an OH, a bond to an OH. It does have 1 hydrogen, let's draw that in. It has this single carbon branch to the left, and it has this big, huge branch thing to the right. Those are 4 different things. So that particular carbon is chiral. So this guy right here, that's a yes. Now, sometimes at this point, students get confused when they're counting bonds to 4 different things. They'll say, well, this is a bond to an oxygen, this is a bond to a hydrogen, this is a bond to a carbon, this is a bond to a carbon. Aren't those the same thing? Wouldn't that make that carbon not a chirality center? The answer is no. When we're doing this, we're not looking at just what's the single atom that's attached. We're looking at the whole entire shebang, the whole entire thing that's attached to that particular carbon. All of it together. So we finally have found 1 chiral carbon. Let's move on to the next carbon in this molecule. This guy right here, what do we have? We have an OH. We do have a hydrogen. We've got this thing to the right-hand side that's got a chlorine on it and some carbons. We've got this other thing to the left-hand side that has an OH and some carbons. And those 4 things that I circled, those are 4 totally different things. So that carbon is also a chiral carbon. So so far we've got 2 in this molecule. So there's another yes. Let's check this guy out. What's going on here? This carbon has a chlorine. It does have a hydrogen. It's got this little branch, and then it has this other big giant thing attached to it. Those things that I circled, those are 4 different things. So that also, yes, that's also chiral. So now we have come up with 3. And let's take a look at our last carbon. This last carbon has got 3 hydrogens on it, 3 of the exact same thing, so that one is a no. We've got 1 more molecule to go. First carbon in the molecule, that CH3, it has 3 hydrogens on it, so that one is no, not chiral. Second carbon, that is part of a carbon-oxygen double bond. Anytime you have a carbon that's part of a double bond or a triple bond, it cannot be chiral. Next guy over, there's 2 hydrogens on this carbon, 2 of the same thing, so that one is also not chiral. Next carbon over, this carbon has this thing. It has a bromine, it has an OH, and it has a smaller little branch off to the right. Those things that were circled, those are 4 different things. So that carbon is chiral, yes. And the last carbon, that's a C8, that's a carbon with 3 hydrogens on it, a CH3, so that one is going to be a no.